All right, let's start it off. Volume of a sphere according to your formula sheet, which you'll get next week on your quiz or on your test. You will get that next week. All right, start it off right here. Aylin, volume of a sphere. Bottom line, you need the radius. I'm done. Nothing else. No heights here, nothing. You need the radius. If you have the radius, you can find the volume. So keep that in mind as we're doing these problems. You need the radius to find the volume. That is it. Right away here, we're going to have a cross section of a rubber ball. The circumference of it is 20 pi. What's the volume? Again, it's going to be a broken record for me today. You need the radius. What do you have in this problem? You don't have the radius. What value do you have? That we're going to have to review again, I believe, here. Kieran, what value did I give you? The circumference. All right, quick review. That's not on the formula sheet. Anybody remember that formula? Go ahead, Kieran, keep going.
Either pi times diameter. I cannot speak.
It's all right. You got it.
2 pi r.
I'm going to use pi d like I usually did in class during the unit 10. Can I get radius from that, though? Yeah, solve for diameter. So I take my 20 pi, substitute it in for the circumference. Go ahead, solve for the diameter. And how long is the diameter here? Theo, how long is the diameter? 20. So that would make my radius 10, and that's all I need for the volume. I wasn't going to give you a question where I just automatically gave you the radius. Make you work for it. 10 cubed. Hopefully everyone's all right on NumWorks typing all that in. Make sure the 4/3 is by itself, not everything divided by 3. And what are we going to here? Nearest 10th. A lot of rounding like usual. All right, talk to me. Nearest 10th. True when you have it. Jacob, when you have it. What? 4,188. Yep. And just another reminder, you're using units. Make sure it's cubic units. All right, moving on. A couple volleyballs. Volleyballs in the shape of a sphere. I give you the volume of both. How much does the radius increase from the partial to the fully? Okay. So I'll give you the volume, and I want to know how much. I don't want to know what each radii is, but how much did it increase going from the partially to the inflated? So let's talk partial first. Four thirds pi r cubed. Let's see, what's the partial one? $1.80. Oh, whoa, hey, what's not on both sides and won't cancel out? The pi, so don't assume that. All right, you just can't get rid of it. There's nothing with the 180. All right, what do you want to do on both sides first? There's 2 moves I can make. What move would you like to make first on both sides to eventually get the radius by itself? Will?
Divide by pi.
Sure, we can divide by pi, and then we're going to have to multiply by 3/4 or divide by 4/3. So I'll let you guys go ahead, and Will and I are going to divide by pi first and get rid of the 4/3 second, but if you'd rather go in reverse, do so. I'm going to do that on my NumWorks calculator as well. No matter what we went with, everyone make sure you get 42.97183463. That's r cubed, remember? That's r cubed. I know I showed you this, might have been this unit or definitely the last unit, or during the area part of this unit anyway. If that's r cubed, we don't take the square root, we take the cube root of both sides. To get to the cube root, you go to your toolbox, and it should be the second option on your toolbox. And then you can make sure you tell the calculator you're taking the cube root. Final answer here, this 3.5 and change, is that my final? No, right? I have to do something with it, but it's not my final answer. So make sure we write it all out. 3.502632975. And then we're going to do the same thing, but now with the fully with 294 as my volume. I'll let you guys go to work there. Everybody, how about 4.124958406 for my radius for the fully inflated, and then you guys are going to subtract those to find what the increase in radius was to the nearest tenth. And nearest, when you have it, take your time. Not in that much of a rush here. When you have it there, Kira, to the nearest tenth, the increase in the radius. It's not much of an increase, but you can still round it to the nearest tenth.
.6.
Done. Yep. And what are we in here? Centimeters, inches. There it is. Questions? We sure? This was an old Regents question, FYI, old Regents question right there. All right, well, if we have spheres, we can have hemispheres, half of one. So finding the volume here, I just want to make sure this is not on the volume reference sheet. But if I take 4/3 pi r cubes a full sphere, what do you want me to do with it to find a hemisphere? I can either do one of the following. I can multiply it by a half, or options, put it all over 2. It really comes down to how skilled you are in the NumWorks calculator with the fractions. I like multiplying by 1/2 there. So volume of this hemisphere, I'm going to keep with 1/2, 4/3 pi. Quick question to you guys. How about the radius length here? Boom, radius length there for me, Lucy. 14, half of 28. No issues there. Just make sure you cube it. You cube it. You know, we have been talking about circles a lot. And maybe it gets squared. It's cubed. Here we go. Cheer when you're ready there. What do you got? 50, 5,000.
5,740.
You're right. Yep. 0.0. Yep. Cubic feet. No issue so far with the volume of spheres. Can you find the radius for me on this next one? Find the radius all on your own. Or if you want to work with somebody around you, that's fine. And then we'll do 5 and 6 as a group. Now you're going back to a sphere now. Catherine, your radius length when you're ready. Can't get into what?
I can't get the number to go under the cube root.
Just say, okay, if you had it, you see how you have good. I'm glad you told me that. Now remember, what do you have, a decimal up here? Remember, you can always hit answer and it'll put that previous answer wherever you need it. Okay? So you can do cube root and just hit ANS and it'll put the previous answer there.
2.7.
You did, what'd you do first? You divided by pi or what'd you do first?
Multiplied by 4 over 3. I don't know.
Oh, you don't want to multiply by 4 over 3 because you have 4/3. You want to multiply by 3/4, right? And that gives you 33.45165. And then you divide that by pi. Okay, and then take the cube root. $2.2, all good?
Yeah.
All right, let's keep grinding then. A little bit different here, a little bit different. A sphere inside a cube. What's the volume of that sphere in terms of pi? Not rounded, I just want the pi with it. Well, again, we talked very first thing today. You need the radius. Is there anything I can use up here to find the radius of that sphere? Darn right. The edge of the cube is the same as the what of sphere? The diameter. All right, the 18 I gave you as the edge is the same as the diameter. So don't overthink it. Cut it in half. I'm going to use 9. Terms of pi. Have pi in your answer. So you can multiply everything but the pi. Or your calculator puts the pi there for you anyway, I think. Cheer, what do you have over there?
972.
9. Sorry, I didn't hear you.
972.
Yeah. Yep. Good. 972 cubic centimeters. All right, I set you up for the final one. All right, this one was like, oh, why do you want us to do this? This isn't that bad. All right, because I'm setting you up for this one. Of course, our boy here, Big Al's got an issue. He's got a rubber ball with the circumference of 13. He wants to box it for a gift. Oh, what a gift, huh? A rubber ball. Who was a lucky person getting that? But he's only got cube-shaped boxes with 3, 4, 5, and 6-inch sides. What's the smallest box that he can fit that bad boy into? Ooh. Oh, okay. Okay. What's the smallest box? Well, probably first it would be nice to find the volume of the rubber ball. All right, volume of the rubber ball. I did not give you, hopefully we're not plugging in 13 anywhere for radius. That's the circumference. So just like we did in the first problem today, we'll use pi d, plug 13 in. Unfortunately, no pi's cancel here. Bless you. We're getting the diameter of this rubber ball to be about 4.13802.852. There's your diameter. Go ahead, cut it in half so I can plug it in my volume formula. So the radius of this gifted rubber ball, 2.06901426. And let's find the volume of the rubber ball. Plug that in there. So we can move on. How about the rubber ball being about 37 cubic inches? Yes. Say that again?
If you know the diameter, you know the box that fits in.
We could go that way, right? We could go that way. Yeah. Actually, that's not what's going to be here. No.
No, but that actually makes sense. The volume could be smaller. You should have a box that's like this and like this tall. The volume is smaller of the thing that fits in it, but it's like really tall.
Everyone find the volume, 37. Oh, I don't know where we're all going here. We still got 11 minutes. How do you find the volume of that 3-inch box? Base times height, right? The base will be 3 by 3, and the height will be 3. 27 cubic inches. Well, my ball's a little bit bigger than that. Takes up more space than that. Next up, 4-inch. $64 cubic inches.
Yes.
We're gonna fit in there.
Yes.
There we go, 4-inch.
Nobody's right though.
That's a proposal.
Can you look at the bottom of your notes, please? Can you look at the bottom of your notes? Please be aware on number 29 and 31A, it will also ask for what's called surface area, and we don't do that anymore. We're just finding volume. Okay, so make a little note there, 29 and 31A, it's volume only.